Welcome to EPG Pathshala lecture series in computer science. This course is on operating systems. In this module, we will learn file systems. The learning objectives for this module are to understand how a file system can be mounted, to understand different issues related to sharing of files, to understand what is meant by consistency semantics and how this is being handled in different operating systems, to understand different issues related to file protection. So, first we will learn what mounting of file systems is. A file system is the most visible part of any operating system, and you can have file systems in different places, in different partitions. You can have file systems in disk, you can have file systems in pen drives, etc., and so on. But to access a file system, the file system has to be mounted first, and only then you can access the file system. And you can have even a single file system that is built out of multiple partitions, or you can have a number of file systems in each of the partitions and so on. So, it is possible to have a number of file systems in different places. So, to attach different file systems together into one file system, to logically attach them into one file system and to view the files in different file systems, we need to mount one file system onto the other file system. So, this is being accomplished by using this mount command. The mount command takes as parameters the name of the device containing the file system which is to be mounted, and the location in the current existing file system to which this mounted file system should be attached. And this directory or the location at the file system where the mounted file system should be attached is called the mount point. So, look at this figure. Here you have an existing file system which has got a root directory, and beneath the root directory there is a directory called users, and beneath this users directory there are two other directories, Bill, Fred, etc., and so on. And you have another file system with the root and Sue and Jane as subdirectories, and this file system is kept in a different device. Maybe you can say it is kept in a kept in a USB or say a pen drive. And this file system which is kept in the pen drive, you wanted to attach it to this existing file system, and for that we need to specify the name of the device or the name of the device file which has this file system, and the name of the directory here to which this root has to be attached. So, suppose say you are using this users as the mount point or the directory to which this new file system should be logically attached. So, now what happens is that after this mounting is done, this root file system in this root directory in this new file system will be attached to this users directory, and thereafter the subdirectories of this users directory will be not seen or will be hidden. So, earlier you had the subdirectories Bill and Fred, but these subdirectories cannot be viewed now. After mounting this file system or after mounting this file system or attaching this file system to this users directory, thereafter the files or the subdirectories that can be seen will be this Sue and Jane. So, while mounting, the mounted device should have a valid file system. So, I told about pen drive having a file system. So, the pen drive should have a valid file system, and only then you can attach that file system or you can mount that file system onto the existing file system. Now, actually what is done is that during this mount operation, you do not actually copy the files beneath the mount point. So, you have a number of files in the mounted file system, and those subdirectories or directories will not be copied beneath the mount point, only a logical attachment is being done. So, how is this logical attachment done? You have a mount table that is kept in the operating system or kept in the kernel. This mount table will have information about the mount point or the directory to which the new file system is logically attached, and it will have the device file's name of the mounted file system. So, the mounted file system is kept in a device, that device will have a corresponding device file name, and that device file name will be maintained in the mount table or will be kept in the mount table. So, once you are moving through the directories of the existing file system after mounting, and when you are finding that particular directory is a mount point, you look into the mount table to find out where or from where the new file system is being attached to or mounted onto the existing file system. And the mount point to which you are logically attaching this mounted file system can be empty. Then if it is empty, then after attachment beneath that mount point directory, you will have this new file systems directories. It need not even be empty as well, as we saw in the example now. If it is not empty, then after mounting, the subdirectories of the mount point may be hidden. So, we will see how the directory or the file systems will be seen after mounting. So, in the earlier example, the users was the mount point or the directory to which the new file system is being attached. Users had other existing subdirectories, but those subdirectories are now hidden. You have the subdirectories now as sieve and chain. These are actually the subdirectories beneath the root in the new file system, which was actually mounted onto the existing file system. So, this mounting helps in logically attaching one file system onto another file system. Now, we learned different issues related to sharing of files. Say when one or more user want to collaborate or want to work together, they may have to share files, and because of that different issues may arise. If it is a single user system, then in that case you do not have to really worry about file sharing, because there is no file sharing at all, and you do not really even have to worry about protection of those files. But when you have a multi-user system, when many people try and access the same file, when many people share the same file, it is necessary to have protection and access controls for this file sharing. So, for this systems use concepts like owner and group. That is, the person who is using or creating a file is called the owner of the file. So, he is responsible for changing all the attributes of the file. He has got more access control over that particular file, and he can grant access to others for that particular file. And then you can have another group of users who are not actually the owner of the file, but they can use the file, they can access the file, they can have some limited kind of access over that particular file. So, the group will be a subset of users who are sharing access to that particular file, and these there will be IDs that have been assigned to the owner, IDs that have been assigned to groups, and these IDs will be stored along with the other attributes of a file. File has got attributes like size, name, etc. and so on. Along with these attributes in the file control block, maybe the user IDs and the group IDs can also be stored. So, in the case of Unix, if you look at Unix as an example, there are owner, there is a person called the owner, and then you have a group of users who will be given a different kind of access permissions, and then there will be the other people. So, the owner will have a different kind of access permission, a group of people will have a different kind of access permission, and then you have the universe or the others who will have yet another kind or yet another set of permissions over that file. And even when you have multiple local file systems which need to be shared between different users, but the file systems are local within a particular machine, then in that case this ID checking and checking for permissions, everything are straightforward once the multiple file systems are mounted onto a single file system and users can use that. But what happens when you have file systems which are placed in different places across the world? So, with the advent of networks, it is possible to have communication between remote computers as well. So, you have a number of resources that are kept across the world, and all these resources can be shared by different users across the world, and file is one such resource, or file systems are one such resource which can be used by users across the world because of this possibility of communication through the networks. And how sharing of resources or sharing of files across the world is possible? One is to manually communicate between different users and manually use programs like file transfer protocol, and you can transfer programs manually. The other way is to have distributed file systems where the remote directories are visible even from a local machine. And the third way is to use the World Wide Web, and the browser is used to gain access to a remote file. So, from a browser using the World Wide Web, you can try connect to a server and use the files that are present in the server. And you have this client server model which allows clients to mount remote file systems from the servers. So, you can have a server which can serve multiple clients, and one client can also use multiple servers, and the browser in the client, from the browser in the client you try and access the servers, the files that are kept in the servers, and there can be some kind of authentication that is being done in this client server model as well. So, in the case of Unix, there is a standard client server file sharing protocol called NFS, and in the case of Windows, the common internet file system is used as a file sharing protocol. Now, when you have this file sharing concept, what happens when there is failure? Suppose if you have local file systems, then the file systems can fail because of a failure of disk, corruption of the directory structure, the disk controller failure, etc., and so on. But now, when you have remote file system, what happens? And in local machines, it is also possible that the errors caused by the users or the system administrators can also cause files to be lost or directories to be deleted. Unknowingly, the administrators can delete a file or delete a directory and so on. But when you have remote file systems, there are more new failure modes. That is the reason is because that in remote file systems, the problems can arise because of the failure in networks or the failure of the server. So, here in remote file systems, the communication is possible only using networks, using communication networks. So, if there is some problem with the networks, if the network is congested or if the link is down, then it becomes difficult to access the remote file system. Or say the server gets crashed, or if the server gets shut down and so on, then again it becomes difficult to access the remote file system. So, the interruption of networks can be due to the failure of the hardware, maybe some problem with the switches, interconnecting switches, poor hardware configuration, the hardware, the switches, the routers not being configured properly, or even due to network implementation issues. Suppose say your client is using a remote file system, and what will be the client doing? The client may be opening the file in the remote file system, or it may be reading the file, or it may be writing the file or closing the file and so on. But suddenly say if the server crashes or if the server gets shut down, then what will happen to the client? The client is halfway through say reading or writing or opening or closing and so on. So, the client will either have to terminate all its work whatever it has done till now, and the client has to terminate, or the client will have to wait for some amount of time waiting for the server to come up. So, the problem with termination is that say if the client decides to terminate and even it should have done lot of work earlier, all those work will get lost, will be of no use, and you will have loss of data. So, most of the protocols what they do is they allow delaying of operations so that the remote host becomes available again and you do not lose information by termination. So, recovery from failure can involve state information being maintained in the client and the server. So, if the client and the server say if they maintain proper state information about what had been happening till now, then even if there is a failure, there is a possibility, or there is it is easier to recover from that failure. The NFS file system but implements a stateless distributed file system. It includes all the information in each and every request. There is no state or previous state that has been remembered or maintained. Only in each and every request information has been included and sent. So, this allows easy recovery, but the problem is there is less security, because there is a possibility of forged read and write operations to happen in each and every operation. The next issue that needs to be looked at when you have file sharing is this consistency semantics. So, consistency semantics, what is it? It will specify how multiple users can access a shared file simultaneously. Say a file is being opened and multiple users can share that file at the same time, then how will the reads and writes be seen to the other users? So, will the writes be seen to the other users immediately, or will they be seen only after the file is being closed, or will the writing be seen only after a particular session, and so on. This varies from file system to file system. So, this consistency semantics will specify when the modification of data by one user will be seen by other users. So, for this they use a term called file session. This file session is nothing but the series of operations that happen between the opening of a file and closing of a file. So, always when a file is to be accessed, the file has to be opened and the accessing of the file will happen, like any operation that you can do on the file will happen, like reading, writing, etc. and so on. And after that, finally that file has to be closed. And this in between, the operations that are happening between the opening and the closing is called a file session. Now, this consistency semantics is being taken care of in different ways in different file systems. The Andrew file system has got something called a session semantics. In this, when one user is writing to a file that is open, and say if there is another user that is accessing that file, this writing that is being done by one user will not be visible immediately to the other users. So, even if there are multiple users who have opened the same file and one user is writing into that file, the other users cannot see what this writing is being done. Only when the file is closed, the changes are seen by other users when they start new sessions. So, even if a file is being closed by one user, but say if other users are continuing the earlier session, the contents that are being written will not be reflected. So, already open instances do not reflect these changes. Only the users who are newly starting a session can see the changes that have been written to the file. So, writes are only visible to sessions starting after the file is closed. And then we have different kind of semantics that has been used in Unix flavored file systems, where you have write to an open file is visible immediately to other users who have the file open. So, here there is only a single image of the file that is being maintained, and that interleaves all the operations regardless of their origin. And the third category of this consistency semantics is immutable shared file semantics. So, as a word you can see from the word immutable, it is saying that the contents of the file cannot be altered at all. So, once a file is declared as shared by its creator, or when a file can be shared, it cannot be modified. So, if a file is to be modified, then it cannot be a shared file, or shared files can only be read only files, only the other users can read from the files, it cannot be written or modified. So, it is called immutable shared files semantics. And now we will see different issues related to protection of files. So, when you have files, you need to keep the file safe from physical damage, which is also called as reliability, and you also have to protect the files from improper access. So, for reliability, what can be done is that you can have duplicate copies of files being kept. Say you have files that are kept in disk, then periodically you can copy those files, add to tapes, and you can store them. So that even if there is some disk crash or some failure of the disk, some sectors go wasted and so on, your files will not get lost, you would have stored them safely in tape drives. The other way is to go for this protection, that is what kind of access control can be given for files. So, the file's owner or the creator, he should be able to control like what can be done on a file and who can do what operations on a particular file. So, the different types of access that can be controlled are the read operation can be controlled, the write operation can be controlled, execute, append, deleting, listing the contents, renaming, copying, etc. So, all these are different operations that can be done on files, and all these operations can be controlled. You can define like who can execute or who can do these operations, and that can be designed. So, one such way in which access control can be given is to have an access control list. So, in an access control list, with each file an ACL or a list will be attached, and you can even attach or associate an access control list for directories as well. So, what does this access control list have? It will have the names of the users and the types of the access that is allowed for each and every user. So, all these will be maintained in the access control list. So, whenever a user is requesting access to a particular file, the access list will first be checked. So, if that user has got the corresponding access, then he will be allowed to access the file. Say for example, say user is trying to read from a file. Say a user called Jane is trying to read from a file. Then for that file there will be an access control list, and within that access control list they will try to find out what permissions are allowed for Jane. So, if read permissions are allowed for Jane, then that access will be allowed, else Jane will be denied access to that particular file. But the problem with this access control list is that the length of the list can grow very large. So, because for each and every file you need to have the list of users and what each user can do on that particular file, that has to be maintained. So, if there are so many users who can access a particular file, then all those users' names will have to be kept in the access control list, and the system should know in advance who all are the users who will use that particular file, and that also has to be maintained. And so, the directory entry will be of variable size, because the directory entry will have the name of the file and the attributes of the file. So, the attributes of the file will have this access control list. So, the size of the directory entry cannot be fixed, because each file will have a different number of users to access the particular file. So, what is done is that rather than having the list of all the users or the names of all the users kept in the access control list, they try to have something called a condensed access control list. So, in this they divide the category of users into 3 categories: the owner, the group, and the universe. In some operating systems, they try to have a combination of this condensed ACL as well as a full-fledged large ACL. So, what is done is that by default for all the files they have 3 categories of access, but for specific files and directories alone they have some more fine grained access control. So, they will have specific access control list only for some files, not for all files. By default all files will have the 3 categories of access: the owner, group, and others. In Unix, directories and files protection are handled similarly. Both are treated in the similar manner, and each file or directory has got 3 fields called the owner, group, and others. And for each of these fields there are 3 bits RWX corresponding to read, write, and execute permissions. So, look at this, say you have the owner, say if the owner is provided all three permissions, say read, write and execute permissions are given for the owner, say, then in that case there is a bit 1 corresponding to each of these accesses, and hence you get an octal number of 7. So, 111 which is 7. Suppose if the group is provided say read and write permissions, but no execute permissions. So, the mode bit here will be 110 which corresponds to 6, and then for the public you have only execute permissions, and hence the mode bit is just 1. So, if you look at the access permission access word, it will be 761, 7 corresponding to owner, 6 corresponding to group and 1 corresponding to public. So, here we can see a sample Unix directory listing. These are the files of a particular directory, and the first file called intro.ps has read write permission for the owner, read write permission for group and only read permission for others. And the second row corresponds to a subdirectory of that directory, that is why you have this D letter here in the beginning, and this has read write execute permissions for the owner, but for group and others there are no access permissions on this particular subdirectory private. But in this directory doc you have read write execute permissions for owner, for group, but for others you have read and execute permissions, but write permissions are not allowed. What is meant by execute permissions in a directory? In a directory, read permission makes sense, you can read from the directory, write permission is writing into the directory. Execute permissions means that you can list the contents of the directory or traverse through the directory and see the contents of the directory. Similarly, for the other files as well, in this row there is the 5th row, you find that the first entry here is a dash before this read, before this RW is a dash. It says that it is not a special type of file, it is only a regular file. But here you have a D symbol here which says that it is a special type of file which is a directory. Since you have a D, it is a directory. So, here you can see that in Unix both files and directories are treated the same way, and you have 3 categories of users for files as well as directories, and each of these categories are being given read, write and execute permissions. Here you can just see an example of a guest user being provided access control. So, it is possible to provide access control for a particular file or directory for different types of users. So, for the guest user, it is provided that you deny full control, you deny modify operation, you deny read and execute permissions, write execute permissions, special permissions, all these can be denied, or you can even allow these to be performed in this. So, this kind of providing access control for different users is possible in Windows as well. Then other protection approaches, another way to protect is to associate a password with each file. But the problem is that passwords should be chosen randomly and they have to be changed very often, and say if you are associating a password with each and every file, then it will be difficult for the user to remember all the passwords that he has assigned for the different files. But if the user is using only one password for all the files, and if that one password is discovered by some intruder, then all the files will become accessible to the intruder. So, if he discovers that one password, then all files protection is lost. Some systems will allow a user to associate password with subdirectories. So, you do not have to assign a password for each and every file. It is enough if you assign a password for a subdirectory, and all the files within that subdirectory can be protected. So, now we conclude here. The summary of what we had seen today is that we learned how mounting can be done, or how you can logically attach a file system onto an existing file system, and we saw different issues related to sharing of files. When there are multiple users who are sharing a particular file, what are the different issues, and this files can even be on a local file system or it can even be in a remote file system. Then what are the issues, and when files being shared, this issue of consistency semantics comes into picture. When one file is writing into a shared file, when can others see the updation in that file, and different file systems handle this in different ways. And then we saw different issues related to protection of files. References. Thank you.